Okay, let's learn a little bit about a process called oxidation reduction. So oxidation reduction are processes that always occur in tandem. One occurs and so the other will occur. Whenever you have oxidation, you're always going to have reduction. So a good way to remember oxidation reduction is this mnemonic called oil rig. So oil rig stands for oil, which is oxidation is the loss of electrons, so oil. Rig then is explaining what reduction is, and so rig is reduction is the gain of electrons. Okay? So oxidation is when a molecule loses an electron. Reduction then is when a molecule gains an electron. So you can see how the two are going to, of course, go hand in hand, right? Because if you have a loss of an electron, you have a loss of an electron, well, something has to then gain that electron. So let's go to this next page here and continue talking about oil rig. And so, talked about the losing of electrons. So you have X here who has this extra electron, and X is going to be faced with this other molecule, M, we'll call it, and M has a positive charge. And so we know already in class that these two are charged, and these two therefore are going to be unstable. They're unstable because they're charged, and they want to not be charged. And so what's going to happen? Well, X is going to give its electron to M, right? Because it doesn't want the electron, and M does want an electron because it's positively charged. So what do you end up with? You end up with X that no longer has that electron, and you have M that now has that electron. So now we've gone from being unstable to, of course, now being stable. And we know when this happens, you have the release of free energy. Therefore, this is going to be an energetically favorable reaction. Now, let's put some more terminology to this. In this case, what happened to X, right? So what happened to X? X got oxidized, correct? It got oxidized because oil rig, because it lost an electron. Right? And conversely, what happened to M? Right? So what happened to M? We'll change colors here. Okay. M, so this is for X, M got reduced, correct? It got reduced because it gained an electron, right? So X got oxidized because it lost an electron, and then M got reduced because it gained an electron, right? Oil rig. So this is oxidation reduction, where you have the loss of electrons being paired with, obviously, the counter gaining of an electron. So just to continue with just a little bit more terminology, in this case, you have to next ask, besides what happened to each molecule, you want to ask, what did each molecule do? So there's a difference between what happened to it and what it did. So we'll talk about X. What did X do? Right? X lost an electron, but it gave the electron to M, right? What happened to it? It lost an electron. What did it do? It gave the electron to M in this case. And therefore, what did X do to M? It reduced it, correct? And so when something gets oxidized, we say that it reduced another molecule. So that therefore, when something gets oxidized, it is a reducer. In this case, conversely now, if we talk about M, what happened, we'll talk about M, what did M do, right? Well, what happened to M is that it got reduced, right? It got reduced. But what did M do? It took an electron, in this case X. So when it took an electron, right, when it took an electron from another molecule, that molecule has lost an electron, right? Therefore, M is an oxidizer because it causes another molecule to lose an electron. Okay? So when we're talking about oxidation reduction, there are two things that are happening. One, what's happening to each molecule, and the second, what did each molecule do? So when we're talking about oxidation, in this case we're talking about X, X is going to give up that electron to M because it doesn't want that electron. And so it's getting oxidized. It's getting oxidized. But what did it do? It reduced M. Therefore, it is a reducer. And then if we're talking about our reduction, our Rig part, we're saying, okay, M is getting reduced because it is gaining this electron. But what did M do to X? Well, it took an electron from X, and therefore it oxidized it, and therefore M is a oxidizer. And so in that previous segment, I said that NADH, in the previous segment, I said that NADH and FADH2, these are both molecules that are strong reducers, right? So what does that mean? So we go look at what our reducer is. A reducer is something that gives up electrons. So strong reducers would mean what? Strong reducers obviously would mean molecules that easily give up electrons. Okay, so now we're going to go into the next segment and specifically look at NADH. And we look at NADH specifically only because FADH2 is very similar to what NADH does and is. Okay, so hope this helps.